right? So Brooks, he had a couple of studies, 1967, 1968, that allowed him to make an argument that that short-term memory gives us an opportunity to do coding, allows us to connect new information to existing information so that it enhances the likelihood of transfer and things like that. So let's talk about one of his studies where he was trying to argue that our short-term memory store attaches visual or spatial codes to incoming information, even when that incoming information might be verbal. So let's kind of replicate one of his study on spatial processing. So he would tell the participants, keep a block letter in mind, and he didn't care what letter you were thinking of. But he would say, just keep a block letter in mind. I'm going to make us all think of the same block letter just so we'll be on the same page, right? So here's a big block X. Okay. Then he would say, imagine tracing the outside of whatever block letter you're thinking of. So we're all going to be thinking about the X, and we're going to imagine tracing the outside of this letter. So as you're imagining that, he'd say, is the corner at the extreme top or bottom? So, I've decided that all of us are going to start where this dot is, and we're going to say, well, it is, yes, it's at the extreme bottom of our figure, right? So we started at the extreme bottom. Then we go up and we imagine here, and we're like, okay, this corner is not at the extreme top or the bottom. The next time we have to turn as we're visualizing, that is not at the extreme top or bottom. Then we go along, continuing to trace the outside. We come to another corner, and yes, it is at the extreme top or bottom. This corner is also at the extreme top or bottom. This corner is not at the extreme top or bottom. This corner is, this corner is, this corner isn't, right? So as we go along, now we're back to the extreme bottom, not the extreme bottom, extreme bottom. So as we go around and we're tracing this letter X, we would be answering that question every time we reach a corner. So if you think of other letters of the alphabet, and other fonts, like if you thought of a capital letter, if you thought of a block letter I would imagine a capital one. Sometimes I's are just drawn, capital letter I's are just drawn as a straight line, right? So imagine tracing the outside. Every corner would be at either the extreme top or the extreme bottom, wouldn't it? The letter F. Some corners would be at the extreme top or bottom, and a lot of them wouldn't be. And so that's the judgment that you make all the way along. And the reason why he's having you make these judgments is because he wants to make sure that you're visualizing this input, this information. He wants to make sure that you're doing a spatial task. So he asks you the question, that way you are playing along and visualizing each corner and giving an answer to the question. All right. So that's his visual spatial task. Then he did a verbal task. I'm going to give you the results all together. But so then he had another set where he did a verbal processing task. In this one, he said, keep a sentence in mind and indicate whether each word in the sentence is a noun or not. So here's the sentence that you'd be provided. It was always, these kinds of little aphorisms that he'd have you say. And you're supposed to go along with each word. For the convenience of us, I've put boxes around what are the nouns. And then you're supposed to go word by word and say yes or no, whether each word in the sentence is a noun or not. So clearly the squares are yeses, and I don't know why I'm the one who made this. I put a yes over worth. Worth is not a noun. So everything should be a no except for the words that have the boxes around it. I only put the boxes around it to make it easier for us to follow along. But in the actual experiment, he would say, think of the sentence, a bird in the hand is worth two in the bush, and then you're supposed to mentally, with no visual cues at all, just mentally think that's not a noun. Bird, yes, that's a noun. In, no, that's not. The, no, that's not. Hand, yes, hand is a noun, right? And so you're supposed to mentally and only verbally go through this sentence and you say out loud yes or no, or you might point, because actually he had two conditions for your responses. So you have that visual spatial task that I described, and I gave you the example of the X. You have the verbal condition where you were provided with a sentence. And then your response opportunities were to either say yes or no, to each of the questions out loud. So, yes, the corner is at the extreme top or bottom. You'd say that out loud or in the verbal condition. Is it a noun? You'd say your answer out loud in the verbal condition. In the visual spatial condition, you would point to the yes or the no response each time, and you don't say anything out loud. You just use the spatial response of pointing right or left. So that's the very complicated design that he had. The results are that people who had a visual spatial task and a verbal response had the best memory for the material later. The next best memory came when they had a verbal condition and they did a visual spatial response. But that's not a ton different from when they had a verbal prompt, a verbal condition, and then a verbal response. That's not a ton different. And honestly, it's not a ton different between the visual spatial and the visual spatial, right? Where you get the best benefit is if it's a visual spatial and you're responding verbally. That's like the best benefit. The rest of these are pretty close. Probably the verbal prompt and the visual spatial response is significantly different from the visual spatial response and the visual spatial input. Those are probably different from each other, but this guy up here, the 11.3, is probably not significantly different from these other two. Here's the point. Brooks came to the conclusion that if you are adding a verbal label to something that is naturally visual, or you're adding a visual response to something that is naturally verbal, you will tend to remember it better over time. And so his suggestion is that one of the functions of the short-term memory is to place these codes onto existing material. And the more varied the codes, the more likely you will remember the information later. So he said that was one of the main functions of short-term memory, was to add these codes onto information that you're going to be storing. All right. Now I'm going to make a little bit of a jump real quick to a couple of demonstrations for you to illustrate some factors that sort of support the processing in short-term memory. All right, so this first one is, I want you, and you can pause me and actually play along, because this is an easy one to do even if you're listening to me as a video. So you can play along. I apologize if you're not in the US, but so what I would like you to do is, in any order, write down the names of as many presidents as you can think of in just 30 seconds. So just give yourself 30 seconds and write down as many presidents' names as you can just from memory. So go ahead and pause me if you want to play along. All right, I'll assume that you're back from having paused me, or you don't want to play along. All right, so hopefully you have a little list of the presidents that came to mind in just 30 seconds. All right, and now I'm going to show you the actual answers. So in case you're not sure, and I know the printing's kind of small. Typically in my classes, when I do this demonstration, people will remember whoever is currently president. So hopefully at the moment when I'm recording this, it's 2023. And so hopefully you wrote down Biden as a recent president. People tend to do whoever is currently president. Sometimes they'll hop a couple back where they'll like write down Obama maybe. They'll tend to hop back a little bit, but not too far. Sometimes they'll skip the most recent one and they'll forget to write down Biden, and they'll write down Trump, not because they think Trump is president right now, but because they just sort of forget the most recent one for some reason. So that you probably have one of those last three written down, maybe even the last row, maybe. Almost everyone writes down Washington. I don't think I've ever had a student say that they didn't write down Washington. Like almost everybody writes him. I've had a lot of students skip Adams, I have to say. Poor Adams, being number 2 seems to not be to his benefit, because most of my students don't remember Adams. But I recently, in the past probably 10 years, I've seen more people writing down Adams. So something must have happened historically that people are remembering him. A lot of people will write down Jefferson. So being third or being on money or something, I don't know, makes you more memorable. Then we start getting into the nameless rabble that happens between, the 4th and honestly the 16th. A lot of people will write down Lincoln. A lot of people will write down FDR, who was, let's see, what number was he? 32nd. So it's kind of like we forget 4 through 15. We forget 17 through 31. We maybe remember FDR. We maybe remember JFK. Sometimes people will write him down. And then pretty much it's a hodgepodge of maybe random other people that some people remember, but those are the big ones: Washington, Jefferson, Lincoln, FDR, Kennedy, and then whoever's the most recent president, usually. So that's it. And then I'll say to my students, okay, so why? Okay, first off, let me tell you what this really illustrates, and I'll ask another question. Um, okay, so I thought I had a chart coming. Okay, well, I guess I'll just ask you a question then. I tell the students, why do you suppose you remember Lincoln, FDR, Kennedy? Why do you remember them and not the other people who are in the middle of the list? And oftentimes they'll say, oh, well, they were assassinated. Well, you know what? Other people were assassinated too that are not on that list. Um, I think it was McKinley. I'm trying to look at the dates. Um, was it McKinley who got assassinated? Somewhere in that. See, I don't even remember, and I've looked this up on purpose. Um, I've looked them up on purpose, and I still can't remember the other people who were assassinated. I don't think the act of being assassinated is enough to make a person memorable, right? Like there's something else that makes them very, what we call in cognitive psychology, distinctive. Something that makes it easy to, sort of like latch on to. When I was a child, Lincoln and Washington each had their own separate birthday holidays. Now they've been combined into a President's Day holiday, and so we no longer have two separate birthdays for them. But when I was a kid, it made it really likely that we would remember both Washington and Lincoln, right? Because we had holidays for them. So there are some, unique distinctiveness that for you might be distinct. Like maybe you share a last name, or maybe I've had students who are related to certain presidents, things like that. So that might be something that makes somebody distinct. Something that I think would make a person really distinct is a person being the only president who has ever elected to two separate terms with a different person in between them. Like that seems like a really distinctive, memorable event. But most of the time, my students do not write down Grover Cleveland. You'll find him as the 22nd and the 24th president. Only person ever elected two separate times, not continuously, but with that break in between, with Benjamin Harrison being in between. Um, that's really unique. That is the only person on this list who had this thing happen, and none of us really know that or remember it because memory, right? It's not meaningful to us for whatever reason. So I want to focus in on why we remember Washington and why we remember, in this case, Biden. There we go. Um, we remember Washington because of the primacy effect. The primacy effect refers to our tendency to remember the first items on a list better than we remember things that are in the middle of the list. So again, this is a graph from an actual study that was conducted, and that you see that the first thing on the list was the best remembered. About half of the people remembered the thing on the list. This was not names of presidents. This was some, like CVC trigrams. So primacy effect refers to the tendency to remember the first thing on the list better than the things that are in the middle of the list. So you see the middle of the list sort of some people remembering some items better, some items worse, right? But basically kind of not very good memory for the stuff in the middle. And then the recency effect refers to our tendency to remember those few things that are probably still in our short-term memory at recall. So the reason why we tend to remember whoever is our last president who is currently sitting in office is recency effect. We hear their name a lot. It's still active in our short-term memory store. The reason why we remember the presidents at the beginning of the list is because those are the ones who got studied the most, talked about the most. Like every class in history sort of starts, American history starts with, and then the first president was George Washington. like this is our starting point. And then the recency effect refers to our tendency to remember those that are still being processed. And typically it'll be the guy who's currently in office right now, maybe to a lesser extent the predecessors, and then we start getting back into the sort of, like I like to call them, the nameless rabble, right? Like the middle of the list that we can't remember. So primacy and recency. Now, things that I want to say about the recency effect, that will go away if you prevent the list learner from rehearsing the material. So if I taught you a list of CVC trigrams and then I distracted you for 30 seconds with math problems or counting backwards by threes from 100 or some kind of, cognitively effortful task, You wouldn't be able to rehearse those last few things that are in your short-term memory, and you're not going to be able to recall them. One of my studies involved learning a list of actual words. They were paired associates, so they were words like, table and chair and salt and pepper and things like that. Um, but they were mixed up. So, like, table didn't appear next to chair and salt didn't appear next to pepper and so on, like that. And what I found is that typically the first things that people would write down on their free recall list would be the items that were last on their list's presentation. So whatever was last. Unfortunately for them, the last two words on the list were what we call buffer words that didn't count because I didn't want to have just a big old recency effect. So the last two words were usually the first two things that people wrote down, and they didn't count anyway because they were buffer words. So I got rid of the recency effect by just not counting the things that they tended to remember the best because it was in short-term memory store. So I was trying to get at whether different kinds of processes produced better memory, and so I didn't want that recency effect. I didn't allow them to rehearse. I had an immediate recall, so they didn't have any time to rehearse or think about it. But I also got rid of the buffer words, and it was really surprising to me. Probably 95% of the participants, the first two words on their list were those last two buffer words. um, because you sort of just want to empty out your short-term memory store, the last things that you were thinking about. Now, if you delay recall for at least 30 seconds, you typically will get rid of any benefits of rehearsal. The strategy that I used on my memory test was I didn't tell them that there was going to be a memory test, so they didn't know to rehearse anyway. I just told them here's a list of words, perform this task on the words, and then when it was over, I said, okay, now turn over your paper and write down as many as you can remember. If I had warned them that there was going to be a memory test, I could have either overtly prevented rehearsal by making them do something in that time after the end of the presentation of the list and the beginning of the recall session, or I could have made sure that there was at least 30 seconds in between, because that would have gotten rid of any recency effects. Here's an interesting new twist. These things were not really available when I was in grad school, so and when I was doing the research on long-term memory and stuff. There's a particular part of the brain, the hippocampus, that gets activated when you're retrieving items that were presented at the beginning of a long list. Let me go back for a second to show you whoops, I'm going the wrong way. There we go. This study that you're looking at here had 30 items on the list. On my research, had 24 items on the list. Typically, we're talking about, relatively longer lists. The list of presidents, that's 42, right? Or are we on 43? No, oh my gosh, we're on 46. I'm caught in a time warp of some sort. Those are relatively long lists, right? So there's a good chance that the information at the beginning of a list of 24 items or 30 items that's being presented to you, fresh, new today, the hippocampus is going to be invoked in trying to hold on to that memory and work it so that maybe if you really need it, you could transfer it into the long-term memory. The recent items, though, those things that are still really just active in this brief short-term memory kind of box, that seems to be activating the perirhinal cortex, which this arrow is pointing at. It's very deep, it's below the hippocampus, right? It's adjacent to the hippocampus, probably easy to transfer into the hippocampus, but a separate area. So we now realize that the primacy effect and the recency effect are probably reflective of different functions of memory, and I won't call them boxes, right? I don't want to say honestly have boxes in our brains where we transfer information as it gets more and more processed, but certainly different parts of the brain are active during different kinds of initial versus longer lasting memories. So kind of an interesting new twist on what we've been talking about for a long time with the modal model. Now there are some arguments against the modal model. The first one is that a lot of the time the information that's in your short-term memory gets lost due to interference, not due to decay. That any time you stop processing or rehearsing what's in your short-term memory, it's probably because you started thinking about something else. And that's objectively interference. It's not just strictly decay. And so they've been sort of debating that. Is it interference or is it decay that's actually causing information to be lost out of a short-term memory store? The outcome's the same. Like it means it's gone. So the outcome's the same. What they're arguing about is the mechanism that's causing that information to get lost out of short-term memory. The coding issue has been argued because they've argued that attaching visual cues to verbal things or attaching verbal things to visual cues, these are things that happen not just in short-term memory, but these are also connections that happen in long-term memories. So how do you separate out that it happened in short term versus it happened in long term? Maybe this isn't a unique function of short term memory. Maybe we don't need to invoke a short term memory store to explain that coding happens. And then finally, when we look at amnesiacs, where we talked about the anterograde amnesia, it's not true that they can't learn anything new. It's not true that they can't form any new memories. They can't develop new what are called explicit memories. And we're going to study this in the next chapter, but explicit memories are those things that you know, and that you can tell other people that you know. Those are explicit. Implicit memories are things that you may not even know that you're aware of until the context demands that you reveal it. And so implicit memories might be, you've never driven you've never driven before, but you've been the passenger on the ride to this destination many times. Let's assume you've got a driver's license and stuff, but you've just never driven the route before. And one day you have to drive the route yourself. Your normal driver's sick or something, so you have to drive it yourself. And you think to yourself, I'm not sure I really know the way. I don't know. Do I know where? And guess what? Now that the context is correct, you reveal that you actually do know the route. You are completely aware of where to turn and when to stop and all the things. That's an implicit memory. And they have been able to show in cases like HM or cases like Clive Waring that they can actually encode implicit things like the procedures involved in a particular game. They may not remember who's winning or whether it's been their turn yet or not, but they will remember the basics of the game, the rules, the procedures, things like that. And it could be a brand new game. We taught it to you today. The problem that the amnesiac will have is in remembering the details of the game, who won, stuff like that. But what they will build on day by day is learning the procedures of it. And so that's an implicit memory. So those are the big arguments against the modal model. They're basically all of them are arguing that you don't need to invoke a short-term memory store in order to have the outcomes that Atkinson and Schifrin attributed to the short-term memory store. So that's the basic argument. All right, let's go ahead and stop here, and in the next one we'll talk about working memory.